I open menu. Yeah, it's late. I've been to a chess club, so I just got home. Third. I can't really test it. Can't test that. Why the hell do I not 7277278? What the fuck? To the power 768. Yeah. No. Right. No, I guess my clipping works. So I did draw what is it? A circle here outside of the window, and that did crash. No longer. Let's commit this. Quit. I'm a running Arch, by the way. Arch Linux. Good diff status. Holy many changes. Renamed a rectangle to geometry. Added an accessor. Only do that when stroke events. Stroke extents is not non-existent. I move this out of the header, so we know we can call clip with the geometry of the layer. Same. Update the X label and the or the Y label in case of keep ratio. That was something else. Create connector. Ooh, the whole connector support is still not committed. I added an intersect rectangle, which works best with just the 4 doubles for the corners. We added a clip, so we can clip with the geometry of the window. Accessors there, another assert. It's not really necessary, I guess, because I'm already testing this inside cairo rectangle in debug mode. Let me remove this. What is that? The out entering stroke extend set path. Why is that commented out? guess I thought it's not really necessary anymore. I don't know. Yeah, I should change this as well, I guess. Adu, how did you make it look so classic? What do you mean? What is classic about it? I changed styles a lot, and in the end I just got stuck on this style. I must say, I'm not really a fan anymore of having it like this instead of like this. But the reason I decided to have the braces always in the same column, it's actually to do with my editor. It's for indentation, so maybe it's just a not a good decision, or not a good reason rather, that to use this instead of that. The problem is, say, if we want to indent all this code, then the easiest way, well, the correct way in this case would be to select everything that you want to indent and then press larger than, and then it's indented. But the selection takes a long time, so more logical is that you use the braces. So I jump to a brace, any brace, and then I do Shift V percentage, and then I can indent it. But now I selected also the first and the last line. Or the whole selection is not necessary. You can just jump to it and then press larger than %. But it's still, and you know, it did indent class as well. I don't know, I can't even remember anymore, so long ago it is. But at some point I decided to, because of my editor, it's just, maybe it's just also better visible. You see which brace belongs to which brace. Maybe not as good here for the classes as it would be for if else and stuff like that. Yeah, I said 10 years ago I decided that it was really after decades of changing and trying, and at some point you make a decision for the rest of your life to have the braces in the same column, except for the namespace. But I don't do that for the namespace. Everything else is always in the same column. And so on for all the other styles. I really made a decision about it based on a reasoning. And that's how I ended up with this style. In the meantime, I've got what I was doing. I was going to change this. The overshoot depends a bit too much on the position, I guess, or no, on the no, on the arrow style, of course. So I should do a switch on. Oops. Switch my shape style something. Can use shape style. Shape style is this, and then we can use this shape here. Which then gives me shape enum. Oh, right. But we're talking about arrows only, I think. So I'm just going to do this. Oh, what the hell, man? Undo. Turned out to be the same file. Yeah, the default stops the compiler from complaining about all the other shapes, but it also catches the no error, I guess. Although, yeah, no error. I don't even care about that, what the value of the overshoot is in that case. But let's say just to stop the compiler from complaining. Did I just delete my difficult formula? No, I have it here still. So this is the case for open and filled arrow. In the case of the diamond, I think we have to use half the width. I only see one. Oh, I see two width actually. So this becomes half, and then this becomes also half the width. And in the case of the arrow shape, yeah, I think I'm going to use half the line width. Oh, it's better, probably. Hopefully it still compiles. I think I'm just going to compile, commit everything. Add connector, some modified was already added. I don't know, man. Veep. Work in progress, aka I'm too lazy to describe everything. Push. Why is this commented out? Parallel lines. Right, let's move it down a bit because, or maybe just change the range. -1 till 4 or something. That would be good. So for -2. 3 not enough? No. Don't want to make it larger really. Just shiftable. Shift everything. Great, now it's visible again. Okay, let's draw a line through this point, perpendicular to L0. To parallel to this one, so the same style we'll do here. Through this point. So I'll already have this one through P1, and now I just want to replace P1 with that point, which is the end point of the 0. Hi Shuffle. Redefinition. Oops, I have to name it differently. I'm out of ideas for names. Don't even use those names. Just to keep the line alive. If you destruct this object, then it disappears again. Let's call this E line. Whatever. I don't care. Make. I need to know this length from here to there, and we can determine that. We can calculate that with incredible precision, namely it is depending on thought it was just purely a function of E itself somehow. Yes. Yeah, I have to draw a line here in the middle of the two. And then you see how it is a function of that. Let's draw that line. So I want to draw a line through I that is in terms of angle in between D0 and D1. Okay, goes through I, it's the intersection point. And then we can pass a direction. We can pass an angle even, because then it will probably understand what I mean. So I need D0. I think I'll do D0. I can create it, and I could create a direction from a vector. I think that should be. Actually, why not just do D0 plus D1? Let's use a line style. I have a D line style. It's line style, so we have just line style, and then with a different color. The line style with a different line color, I guess that it was. Let's use, I have no idea what big color. Teal. Oh, I was gonna say I don't even know what the color, what they look like, but. Peach. Hey, my cursor doesn't know what peach is. That's a bit too light. Gold. Nah, 10. Maybe. I'm gonna go over to turquoise just because. Mm-hmm. Oh, I need a point. What? I need a point? So it does create a vector. That's one thing. But then it wants a point vector to. Oh, it cannot convert vector to direction. Ah, yeah. I didn't want to do that implicitly. So I have to explicitly tell it to convert this to a direction. No, I'm not sure, of course. But this would be the direction in between these D0 and D1. Isn't it? Now there it is. Now note that this line is perpendicular to E. So I almost have to blow this up, man. And this E is in the way again. I want to put E under this point, maybe, or to the left of the three quarter point. Anyway, somewhere here. Could put it below this point. Next to this point is more logical. So a quarter from this point and then to the... Yeah, actually to the side, right? I can only put stuff now aligned with x-axis, like straight down or to the left. Thinking it makes more sense to be able to put labels in a certain direction using a direction vector. Say this point and then that direction, perpendicular to it. That would definitely be better. Let's put E for now where it is here and then a bit down. It's 5, 10 points maybe. The below, I have to do centered below, I think. So now it's on the right of, but we want to have it below. And I want, I don't think 5 pixels is enough, so the default is 10 pixels. I think that will work. Yeah. So this is E. And I have here this little triangle, and I think I have to blow it up because can this be blown up by means of the changing the range? Like minus this point here till there. I cannot remember that, of course. I should be able to remember that. Come on. Minus 1.75 minus quarter till a half 0.75. I can never remember that. Never. And I also don't see a pen. Oh, here's a pen. Okay, already forgot it. What did I say? Minus 175, comma minus 0.25 to minus 0.5 to 0.75. Let's try that for a moment. Edit this and I type in range. Should get me in the orange and the range. Keep the old values. So the X range runs from minus 1.75 to minus 1.5, minus 0.5 I mean, and then the Y runs from that to, and even that, 0.75. Zoom in, manual zoom in. Oof. So since this is no way. It's not that simple. Well, I know this length, yeah? That's the known length. This is half of that, so this is a known length. And I need to have this length here. And this is 90 degrees. But there is no other angle of 90 degrees, not here. this angle is equal to that angle. So this angle is equal to that angle. That doesn't help much, does it? This is 90 degrees. Yeah, well, how does that help me? Oh wait, here's 90 degrees. This is 90 degrees. And this is 90 degrees. Must be able to do something with that. Oh yeah, this large rectangle here shares a corner with the small one. So this small one here shares this corner with the large one, and both have a 90-degree rectangle. So therefore this little angle here equals the half angle here. Congruent triangles. Which means that yeah. And this length here is d0 from here till there. So that's a length of 1.000000000. I like the accuracy of that. Can you hear it? Very accurate one. So this divided by that. No, let's do the other way around. This small angle here, and then this divided by that is the sine of this angle. The sine of this angle is this divided by that. And I know both because this is 1. So the sine of this angle is half of the length of E. And the sine, this angle is the same angle because of congruent triangles. And the sine of this is that distance divided by this distance. Which sucks because I only know that distance. But we can use Pythagoras maybe. See, I'm trying to do this from my head with this picture, but no pen and paper is required. Can't help it. Plus I need light. Still no light. I feel like making it clickable, you know. I just click here and then it detects that I want this corner here. And then I say, yeah, that corner, yeah, that angle, yeah, please enter an arc with a text symbol in it. Like, you can just put a star here and then a star there and stuff like that. But then I'm working on a completely different project suddenly. I can't do this. I have to stop at some point, I think, with this drawing shit. Anyway, let me draw this on paper. Length 1, triangle, 90 degrees. And then there is a line here, which is perpendicular to that one. 90 degrees, and therefore this angle equals that angle because this angle equals itself. This length is a half the length of E. We can just fill it in. This is the square root of 1 minus the square of a half. I'm going to do a quarter E squared. Man, that half really sits in the way. Maybe we should call E. Maybe we should call this E. Not sure what in the end I want to use as E. I could call this E, and then, but then eventually I want to calculate that length, and then no. This length is difficult to calculate. You just forget everything on this side. Is that possible? Can I just go with this? I'm back at thinking that maybe this line in the middle is important. Base everything on that. I do that, and I should probably draw a line perpendicular to the blue line here, or a maroon line, or a turquoise. What did I choose? This looks like 90 degrees, but it is. Oh, it also is. It just fucking is 90 degrees. So then we have to, yeah, I could just straight use this. If I use, if I want to have projection on this line, so it's kind of easier because I'm bang done. This is the length. E. No need for that line. But then I have to zoom out again and then see how it is on the other side. Yeah, I don't know. I think. $90. Maybe. Anyway, I do have this length now. Wrote it down on my paper. So it is this length divided by the square root of 1 minus this length in a squared. So it is indeed just a function of this cell length here. Let me go back to the larger picture. So yeah, if I would work with this length here, I would probably have to project onto this line, which is problematic because I don't have a point on this line. Yeah, we just have P0 and P1. So you can project P0 along this line onto that line if this is 90 degrees, which is why I draw this through this line. This is not very well possible. So the opposite it would be, that's the same length. I mean, it's just always the projection of this line piece onto something. And I think we only have the line perpendicular to this line. Well, or the line itself. I could project P1 onto this, you get that. Or P0 onto that, and you also get this point. And then the other ones are the on D1, so I could project P0 onto D1, of course. Or P1 onto the line perpendicular to L1, and then you get the same point. But we don't know where P0 and P1 are. I mean, they are symmetrical in the sense that P0 could be anywhere on this line, anywhere, and P1 equally. You don't know where they are. So if one is numerically more favorable than the other, I would have to figure that out and then choose the one that is best. I suppose that P0 is better here because it's closer to the intersection point, but then I would first have to calculate the intersection point more or less, and then say, well, but P0 was closer, let's try it again, but then using P0. So you have to do it randomly, and let's then say we start with projecting P1 onto L0, I mean, so we get this point here. Then really the only thing I see is that we can use the distance, this distance here, from there to there. Which is then exactly 1, because that is the D0 here, is exactly 1. So we need to have the ratio between 1 and the total distance, which is the total distance, by the way, is equal to that length, which we just calculated to a very, very high position, and that length. So the goal is now to calculate this length with an as high as possible position. Slightly annoying. That means I need to have this intersection point as well as that one. See, that's why it would have been nicer to have this total length. If if I have this total length, I can just use this length, which is, well, the result of the dot product directly. That would be way easier, right? Then we can just divide, or yeah, divide this length, which is the dot product of P0 P1 with the D0 rotated 90 degrees. That would be that length divided by this length is this length. So we would still need this point, and then we can subtract that length from it in the direction of D0, and then you get to the intersection point. I think I need to calculate this point anyway. The projection of P1 onto the line. That point is going to be needed. And I think I would like this length. So I had this length, but I need that length. I'm gonna calculate this point, I think. Let's do that. So that is, yeah. That is, I think. What is this type? It's P0 to P1. I think a line piece or no? Create line returns a line or line piece, yeah. It's a line piece, isn't it? Just have 2 points. And I can create a vector from a line piece. Or from 2 points, but it's the exact same thing. Probably using the points here, more logical. From 2. Alpha. Alpha is a dot product between this one. How the hell did I do that? Do I have a function called dot? Yep, I have a function called dot. Direction dot. Nah, vector dot. Better. So I can just call, I have a vector and we call dot with another vector. That's it. Okay. Dot the other vector, and that is then L0, the normal of L0. Let's see, L0 is a direction, right? No, it's not. Also, I have a plot. No, I do have an L0. L0 is a line with a direction. Yeah, direction is D0. Hello. Yeah, both work. So the line, a line constructed from a direction just copies it. So it's completely lossless. And then that converts back to a direction automatically. Again, completely lossless. You just get a copy of the original direction. And if I call dot on a vector, then it wants a vector or a direction. No, this is a direction. It wants a vector, but a vector can be constructed from a direction. So if we pass a direction, then that would work. And my normal is a direction, lossless. Created from, wait, this is the normal of a direction, and I would have to first have a direction. But L0 is a line. Does my line have a normal? I don't think so. I thought I were calling it differently. Oh, I'm not calling it at all. I think it should just add normal here. So you can have a direction. Kind of the annoying thing is that sometimes you want the normal, but sometimes you want a negative to normal. Sometimes you want 180 degrees stuff. I added it somewhere, but it's not here. So where did I add that? And how did I call it? And why can't I find it now? I don't think this compiles. Come on. Nope. So there's no normal in line, but I do have a Rotate 90 degrees, I think. Yeah. That's vector. So I can rotate my vectors like that. Yeah, okay. Let me think. If you have a line, you can hardly talk about rotating a line. Well, you can, but and then expect the direction to. I probably should first convert it to a direction. The line, I mean, to keep it logical. And then the direction that gives me has a normal and an inverse. So that's maybe the only nasty thing, that I don't have a 270 degrees one. I'm going to add that one and then we're done. Right. Normal inverse, so that would be, why did I copy the other one? That would be y minus x, the inverse of the normal. Lossless, no rounding of errors whatsoever, so nice. This should compile. Is this a signed length? Yes, it is a signed length. It is that thing. I think it took the normal. So my direction was, I have no idea actually. Who cares about signs? We just try it out and then we change the sign if it's not correct. So I'm going to multiply this alpha with that normal and then add it to P1. Calculate the projection of P1 onto L0. There's a point. And we call it a plot point. No, not yet. Let's call this point, no, Q. The Q is, well, actually, it is P1 plus alpha times that same normal. Is so not going to work, or is it? I mean, I think it should work. And so if it does not compile, I mean, then I have to make it compile. It compiles. Wonderful, wonderful. Let's also plot it. So plot the bloody Q, please. Plot dot add point Q with label Q. I guess I'll just pick something. So point style. I will point label style here. I'm totally happy with that. See how that works out. Not. Oh, well, goes to the point 2. Oh, I have to pass a layer first. Yep. The second layer. Too many arguments for a function call. I'm trying to add a label instead of a point. Not smart. Sorry, add point takes a layer, point, and a point style. So probably just like that, and then point style. Hopefully I have a point style. Totally have a point style. Might as well add a label for Q. Let's see, how did I do the label stuff? Create text, label at the end. Plot a create text. Second layer. Where to plot it? They'll both work. And then the Q. And then the point label style. Hopefully that works. A well conversion from point to const point, very interesting. I would say create text, layer cairo point text style, cairo window point. That should be, this should be cairo window point. What the heck? How the hell can that not compile? It's exactly the same as that one. This works. And I is a point. Well, Q is a point as well. And this is a string, and this is the same thing. There's nothing wrong with it at all. Nothing whatsoever. It's not a plot though. I mean, above I called it a Q label or whatever. It's impossible that it does not compile. Viable conversion from point to const point. What are we talking about? Cannot bind base class of type point to derived class reference. First argument. Passing argument plot point here. Add point? What do you mean add point? I'm doing add point. Why am I doing add point? I'm doing add point here, so the problem wasn't here. What? Yeah, this must be create point. thought it was different line that gave the error. No, it did not work. I'm guessing I have a sign problem because it did not work. So we're going to edit this and change the sign. Well, where can we all change signs? What about this one here? It's a plus. That's the only plus I see. That must be a minus. Professional coding right there. What? We don't have a minus. Oh my god. Yeah, well, okay, then I put the minus there. Same thing. Probably should add a minus, so. And now it works. The Q is right there. What do you guys think should I do next? I think I have to think about how to get this length here. How hard can that be? Pretty hard, probably. Pen, paper. high def data. Yeah, I'm thinking two things at the same time. It doesn't help. One thing is, well, I'm just not happy with using a Taylor series because it's just an approximation. You just go on far enough, then it's accurate enough, and this 11 should be totally enough. But yeah, well, I don't know. Anyway, now I want to write this in terms of x squared. Basically, I have the x squared is e2. So this is e2. Now I get e2 squared. E2 to the power 3. E2 to the power 4. E2 to the power 5. And then guess I want to start at the end. Maybe I should reverse it. Feels like I should reverse it. I don't know why. Let's see. 0, 1, 2, 2, 3. 2 to the power 2 is 2 to the power 3, I mean, is 8. What about 2 to the power, well, that would be 7. Can't do this from my head, man. This is 2 to the power 7, this is 2 to the power 3, this is 2 to the power 0. This is 2 to the power 10, I think, or not. 2 to the power 10 is 1024. Or something. That looks like 2 to the power 15. Already don't see any logic in it unless multiply that by 2. Nah, plus 3, plus 4, plus 3, plus 5. It's hardly worth it. Hardly worth it. I'm just going to calculate all of this. Calculating by integers would be more accurate, I feel, though, but still have to divide it by some power of 2 then. Although, I think dividing by even a double divided by a power of 2, isn't that like accurate without any loss? It's not internally storing powers of 10, is it? I mean, come on. Nah, impossible. Or is it? Damn it. No. Man, what the bloody hell? I don't even know that. Okay, it's a power of 2. So dividing by 2 just means subtracting something from this, which is then 100% accurate. So I really feel like multiplying with an integer, which is also almost exact, and then dividing it by a power of 2. Feels like a bit, how do you call that? Crazy. I'm crazy, basically. Start with over. Over something. What is the ln? Over 262,144 divided by the ln of 2. That is 18. I'm going to try it again. Just like it. 18. And this must be 14 maybe? 2 to the power 14? No, 15. Yeah. 15. This we already had. That was 10, 7, 3, 0. Spots the pattern. Don't tell me there's no pattern there. There's no pattern there. Not really. You could make these integers a little bit larger, though. No. And then have a difference of 4 every time. 19 minus 4 is 15, minus 4 is 11. Minus 4 is 7, minus 4 is 3. Minus 4 is minus 1. What the? So I'm just going to store both separately. 2 tables. Completely crazy, man. Why? Why would anyone do that? Isn't it already stored like that? Yeah, no, I should not do this. That's nonsense. Okay. Finally, I got to my senses. If I have this as integer, that's exact. And if I then divide it by a power of 2, that should still be exact. It just changes the exponent. So the result is exact. This would even fit in a float exactly. Right, and now I want to calculate this. Start with that. Factor is table 0. And then we're going to run over a loop. I is 1, I think. Let me see. I have to multiply by 2 and then add that. Yeah, every time. So 0, 1, 2, 3, 4. Less than the size. Less than 5. No, man. 1, 2, 3, 4, 5, 6. Boop boo. Okay, I think we have a factor. 2 double epsilon is an E2 times that factor. I'm already using an alpha somewhere else. So let's use beta. Do we have more than 4 viewers? I have 4 viewers. Well, viewers. But I'll explain it anyway. Maybe save this first. Oh. So this is alpha, angle between D0 and D1. Beta, I mean. And we want to know this length. Yes, so that is equal to the tangents of this angle, of course, because that would be this length divided by, oops, that's, yeah, the tangent, sorry. This length divided by that length, it's the tangents of this thing here. And that length is 1, so the tangent is equal to this length, which we want to know. Therefore, we want to know the tangents of this angle. And we do know the tangents of half the angle, because that's this height here. Yes, because again, this divided by 1. And that length I calculated before is because of the congruent triangles. This triangle is congruent to the bigger triangle here, the half the angle. Is this length divided by the square root of 1 minus this length squared. So that would be that one. And again, that one is then the tangents of the small angle. So tangents that we want to know can be written as that, according to ChatGPT. So we express it in half the angle, and we do know that one because, well, we calculated that before. And then put all that together and then calculate Taylor series, and then you get weird numbers like that. So I then apply. So vector is that first one, and then times the square of E2. The square of ln E. Yeah, we can only hope that I did not make a mistake. I'll never know, I guess. I'll never know. Okay, we have epsilon, whatever. I'm going to calculate the length of, so the other thing was called alpha. We already have that. Here's an alpha. So now I need to have Q let's not draw I, let's not plot I. So that plot I. No plotting of I. And then I make a new I here, which I now finally calculate. So my intersection point is, I'll have to give it a new name though, because I already have an I. Calculated I equals, Q, I think. Plus some factor times D0. Some factor times D0. Let's try factor 1 and then show this thing. Plot the calculated I. Plot dot create point. The second layer. Add calc I with label. Oh, we don't have a label. Wait a minute. It's just create point with a point style. Yep. So that went that direction. Of course, I want to go that direction. So we need a negative number, and the negative number must be equal to this length divided by that length, and this length divided by that length, and this length is epsilon and this length is alpha. I'm not sure about the sign though, so I'm just going to try it. Something like alpha divided by epsilon. Probably the minus sign in front of it. Totally out of view. What is there? Failure. I thought that would give me my intersection point here. Okay. Let's print the values then. Type alpha epsilon is epsilon. Now find that back. There it is. Alpha is 1.5. Well, does this look like 1.5 to you? Yes, it does. Well, it's not a factor of 10 off. So this is 1.5. This is 1.5. So yeah, it's 1.5, man. And epsilon is like this length. This is like well, ish. It's like a little bit shorter than a half, I would say. On the looks of it. Where is it? Here. Oh, that's like way too small. 0.16, no way, no, it's not 0.16. That's like this distance. Looks like this, we call this instead of the full size. Something went wrong. Something went wrong with the calculation of epsilon. Try that again then. Die uit DC notes, comma len I equals len I. That should be correct, shouldn't it? Then the 0.4 would be a hell of a lot easier to see if I had more lines, I must say. Or I can blow it up again. Yeah, let's blow it up and maybe rotate the whole thing so this line here is horizontal. I don't really need it to be rotated at the moment. So let me use this. Let's zoom in, and then the angle here is 2y1p. Commented out. Let's use that value here. I think about it. Why wouldn't I use minus this divided by 16? And then this one, still that. Now we're talking. So now I can see how long E is anyway. The length of E, that should be this, right? That is... Something went horribly wrong here. Shit. What happened? No, another bug. I think I go to bed. I'm not ready to work on a completely different bug every time. I want to make a little bit progress. Maybe the problem here, the ratio. plot. Keep ratio. That was not it. Oh, don't resize the window. I made a window larger than 1200. Did not like that. 1300. Yeah. Could use a trigonometry. I have no idea how to pronounce it. To give me the values. The exact values, because well, start with an angle. I know this angle, therefore I can calculate the height. That would be the sine of that angle. That is the half the height, so 2 times the sine of the half angle. That is the exact length of E. And at least we have the real value. Let's print that. And I don't want to see X loop event anymore. X loop. It's Cairo. Could turn off Cairo. Let me think. Yeah, of course. We're working with notices now. All this spam. Cairo. Let's not do Cairo. So we get this kind of output. Still a lot, but now here they are immediately visible. Way better. And then I want to print the expected length of E equals 2 times the sine of delta theta. No, delta theta divided by 2. Delta theta is the difference that is equal to the angle between D0 and D1. Half of that is now theta, but I'm using delta theta anyway in case we're going to rotate the whole stuff. Half of that, and then the sine, that would be, yeah, and then times 2. Yeah, that's the length of E, man. So let's do this. And then look for the expected. Maybe we should print that down below. Okay, 0 0.39 etc. is the correct value. That's exactly this, the length of E. So we are still on the right track there. Although I'm going to move that down, I think. Yeah, I guess my Taylor series goes wrong. So the epsilon that I get out of this should be a little bit larger. Definitely want to print a factor. Well, that's pretty much close to 1. Can't complain about that. Epsilon of 0.16 is obviously wrong. Did I multiply it with the len of E squared or something? Yeah, this vector was the tangents of the full thing, right? Which is this divided by 1, which is this, which is obviously larger than E, plus yeah. What the hell, man? I bet ChatGPT made the error here. The formulas are just not right. What else can it be? Going to punish it with a thumbs down. If that's the case. No, this is definitely my fault. It's E2. Fuck. Why? That should have been Elan. Okay. No. Yeah. Great. Undefined. Well, maybe it should not be Elan, but then it should be len E. And there it is. Exactly. I mean the red circle here. Exactly at the intersection. Everything worked out and was my fault. Damn it. Let's put the rotation back. The rotation back where it belongs, as in theta. And then, I don't know, nothing changed. It still works. Oh, well, pretty cool. So here's my intersection point. Calculated. So the idea is then that I, at the very least, I can take this difference, because that's the accuracy of D0 and D1 are no, they just, I mean, if they are not what I tell, what you pass, if you pass a D0 that's already a little bit wrong, then yeah. So I'm going to assume that D0 and D1 are exact, and therefore I can take the difference. Therefore we must have an E that is can be assumed to be exact, the length of that. And then I use a Taylor series to crazy precise calculate this length. There's absolutely nothing wrong with that. Especially not because this angle is going to be like nothing, like way smaller before I even use this. And then the problem lies more on the other side, I think, if there's a problem. So let's zoom out again. Plot here. Of course, we need to get. Well, actually, if in the end I calculate intersection from again D0 itself, which is assumed, well, that it is exact, from Q. So if Q itself moves a little bit around, then which is of course going to be a tiny effect, and I add D0, which is exact, right? So then the intersection point moves a little bit around. It's not moving like that all over the place. So the position of Q is not that important. What is important is the distance from here to there. If that's like jumping back and forth a lot, then we might miss the intersection point. And that distance, I mean, this is also given to be 1. I mean, even if it isn't 1, the D0, it's supposed to be 1. So I'm not even calculating the length of D0. I'm assuming it's 1.000 with an infinitely numbers of zeros. And therefore I can know this length if I know the ratio between 1 and that length. And that ratio is exactly equal to this one, where I said, well, we managed to calculate that exactly, and this length. So the only thing that's left now is how accurately did I calculate this length. If I calculated this length very accurately, then you have really precise point here, I think. The only thing, well, actually, yeah, well, it remains. I mean, D0 is a little bit up and down, you know. So if this is a very long distance, well, the point is it isn't. Both points are on my screen. So even if the direction of D0 is a little bit off, and then we're talking about 1/1,000,000th or something like that, then I would still end up. Okay, we could have a problem maybe if this scale is enormously different. Nah, not really. Oh. The scale is enormously different, then it probably goes. The error goes up, but yeah, also the scale. So then we still don't see it. still gonna be less than a pixel ish. And here we have, yeah, I don't know, man, it's just not possible to make it any more accurate. Pretty sure about that. So this distance, well, this distance is the end product between dot product, sorry, between the difference between these 2 points and the normal of this vector, which is also d0 without any loss. Swap xy coordinate and negate the x coordinate. Then you have this vector, like a unit vector pointing up. Taking the dot product is necessary. There's absolutely nothing you can do about it. Plus, if, for example, you're going to assume that that's not a rotation on the 45 degrees, but it's just horizontal, and that P1 is extremely close to L0, then P1 is going to have the same coordinate. Sorry, the P1 is going to, now the normal of L0 is going to be upward, so it's a 0, 1. And P1 is going to be having a tiny little addition. No, P1 minus P0 is going to be very small. And I think that's the same as the difference between D0 and D1. You just have to assume that that is accurate. That difference is then calculated, that difference is then multiplied by that 1 pointing up. This difference is vanishing, so you just multiply it times 0 because the thing is pointing upwards. And there is no loss whatsoever. You just get that that tiny distance from P1 to L0 to the full accuracy. Okay, something is not right here because it's not right whatsoever. Okay, now I'm confused why this thing is even exactly on. What? I calculated this distance. That's all fine and dandy, but then I need this distance. I did not calculate this distance. I didn't. I think I calculated the distance from P1 to L0, which is this one. So it should not have been there. It should have been a little bit somewhere else. What? Oh my god. Now what? No, I have Q exact. Oh, wait a minute. No. What? Huh? I need to work with the distance between P1 and Q. I did calculate Q correctly. Now I'm so confused again. Well, we worked with alpha. Maybe I did. Maybe I calculated alpha correctly. But let's have a look. Nope. That is not good, man. What the hell is going on here? Q is set to, I mean, I have P0, P1 dot product with the normal of L0. So we project it onto a line that is perpendicular to L0. And then we calculate Q as a P1 minus that length time that same vector. In other words, this must be 90-degree angle. Yeah, no, clearly it's not. So what? How the hell did Q end up here? Flabbergasted. I can't go to bed until I get that one. What the hell, man? Did I recompile? What? What? How many queues do I have? Just one. Okay. I'm completely... I have no idea what this is about. How is this... What is going on here? What the hell is going on here? This should be the same as D0. Hello, Brazil. Bruno, yeah, well, learncpp.com. It's the only thing I know, which is not horrible. Normal, D0 normal, and then here again, of course. It didn't change anything. It doesn't make any sense whatsoever. Really. Why is this? I mean, this line is just drawn through P1 and Q, I think. So it's a calculation of Q that is weird. But Q is calculated as P1 plus some vector times some vector, not a vector, but a vector times some vector. A vector times a vector. But the vector is the normal of D0. So that is along this line, which is impossible, of course. If you add the normal of D0, which points like that, to P1, then you go like this direction. So how can I ever end up in Q? Impossible. This does not make any sense whatsoever. What is going on here? It's so impossible, man. Yeah, Q is P1 plus something in the direction of the normal of D0. And now that's impossible. Now you could say, yeah, maybe this is not the Q, but I will comment this one out. Then the label stays and the red circle disappears because I'm not plotting that Q. It's definitely that Q. Yeah, you never know. Yep, it's gone. See, no more red circle here. So that's definitely that Q. Then you say, okay, then what is the D0 normal? Okay, let's just add a line here. Auto plot foo is plot dot create a line on the second layer. Why not? Through P0 along the D0 normal with some line style. Okay, my mouth is hanging open now. So this line here, this line here is the direction of, yeah, that's why Q ends there. But it's not the normal of D0. Don't tell me. Oh fuck. Oh, it is. Yeah, sorry. I'm getting it. Unbelievable. Yeah. Oh, wow. Yeah. Arg. Okay. Well, I can go to bed. Yeah. Okay. So the reason is that it's squished, squashed, shared. So what is the deformed? It is elongated in the horizontal direction, which deforms my corners. So now I set a boolean that says keep the ratio the same, x and y ratio, and then it's an angle of 90 degrees. This is what you should do. Yeah, if you stretch the thing horizontally, then that is no longer an angle of 90 degrees. I really didn't get it until I finally got it. Yep. So if we have a very accurate position of Q, then we have this length, but Q is calculated from the length to begin with. And I'm using D0. I'm using D0 back and forwards. We rotate D0, then project onto it, then multiply it to get from P1 to there. And then we go following D0 again to the intersection point. That's a lot of D0s. So that's why I say it feels more safe to follow this line. If I had this point, then we could just go there, and then if it misses the intersection, then you would actually see it. Or is it nonsense? Yeah, that's totally nonsense, of course. You would also see it like this. Okay, well, we see it anyway. It is, well, I need to know where the intersection point is before I can see if it's correct. I guess it should calculate backwards. That is, set the intersection point exactly there, and then calculate the P0 and P1 from that. You get double errors again. I think I should just stop. This is good enough, isn't it? Yeah. I'm calling it finished, the parallel lines. Now I still have to move this code to, well, not that code, but at least the bottom to the place where it should go. Oh, kind of this page. But I'm going to bed now. Actually, I'm a bit scary. I'm nicking the length of E here. The tangent is not always positive, obviously. You could argue that the beta is positive, maybe. Yeah, if beta is positive, then it is correct. But that then means that we make a difference between D0 and D1. If I say that beta is equal to the angle that D1 is rotated relative to D0, then it could be negative. If you swap the D0 and D1. Yeah. See the image on my piece of paper. try that out. Say epsilon is 0.01, which is my largest value. And then I get that divided by 2. And then the square of that. And then that subtracted from 1. And then the square root of that. And then 1 divided that. And then times 0.01 again, divided by 2. That is then the tangents, and then I have to remember that. I'm sure I have a memory on this thing, but no idea how that works. I have an M plus. I don't know, do an M plus, I want to store. I'll just write it down. 5.000062501 times 10 to the power minus 3. Duh. And then we do that squared. And then subtract that from 1. And then divide that, 1 divided by that, times 2, times, and then that number again, 5.1234, 62501 exponent minus 3 is... that gives me 0.01, that would be this, plus something, so I'm going to do minus 0.01, and then divide by e squared, I guess, which is 0. Few zeros. How do you do that? Divide by doesn't look good. That does not look good at all. It's not 3/8. Really? Really? God, that would be ChatGPT's fault, wouldn't it? No. I asked Alpha, from Alpha also. I did something wrong? I don't know. Total tangents divided by 1 minus tangent squared. That's correct. And this one is also correct. Pretty sure of that. What's a Taylor series of 2? That's the same thing as there, but the y is x divided by 2 divided by the square root of 1 minus the square of that. Yep, totally. And then the answer was this. X plus O. But no, yeah, that's correct actually. So 3/8 times to the power 3. That one. Yeah. No, I guess I made a calculator error then. While doing it. I should go to bed. Damn it. Someone tell me to go to bed. It's not bad, huh? Is that my error? Don't tell me I've been calculating tangents. Didn't, did I? No. Did I? Did I do that? No, I didn't. Didn't. I hope I didn't. That's what I got to. That's not what I did get. Mine is 10,000. Oh, wait a minute. I did divide. I have to divide by E first, of course. Which is E times that. So we have to divide TP by E first. Then I can subtract 1 and divide by E squared. That's better. I must have done something wrong. On my calculator then. So 3 divided by 8 is 0.375. Yep, that's correct. The next one was 23 divided by 128. One 17968. 1796 there. But maybe that's even the next one then. No, must be good. Well, this is definitely calculatable like that, because it's the square of E everywhere. The sign doesn't matter, but the sign of this one, I'm not sure. I think sometimes we have a plus and sometimes we need a minus, but really. I think he got past that point. I guess I should read this as vector from P1 to P0. So that vector projected onto N0, but N0 points that way. So it's probably then we get a negative thing. It's not the way you want it to. That's why we get the negative sign all the time. To probably use this. Projection from P0 to P1 onto N0. That would be something that points from there to there, yeah. That points upwards. No, it's positive, I mean, sorry. Positive? But yeah, then that. So now we need a negative. Now we need a minus sign. But only because P1 is above P0. Gonna try this. I think that negates it again. Yeah. With a normal image that we normally have, so P1 is here, Q is here, n is pointing up, n0 is pointing upwards, so this must be a negative number. And then p1 to sorry, this is, yeah, from p1 to p0 projected on n0 is a negative number, so this is correct. And then I'm at q, so from there we have to go something times d0, which is then the alpha divided by epsilon, which is and that must also be negative. I'm gonna use alpha like I did before, I think. So we have alpha. Where's my alpha? So my alpha is this, which is a negative. This is then alpha divided by epsilon, which is actually the tangents of beta times d0. I have the feeling that it really is sensitive to the angle between d0 and d1. We can test that out. If I wouldn't have been in bed already for since half an hour, I have no idea how I'm still typing from my bed. So I'm gonna make this one negative, swapping d0 and d1. It's not exactly. If I really want to swap it, I have to change that as well, I guess. Because this way one becomes horizontal. Let's make this minus the current theta and then change the theta to something twice as big. Nothing worked anymore, as expected. Oh my god. Okay, this is P0 here. You I did swap it. D0 is now up and D1 is here, which means that E is pointing down instead of up. L0 is here, so we have the 90-degree angles here. P1 is there. Projection of P1 onto L0 gives us that also looks good. Actually, everything looks good except the intersection point is gone. And it's probably gone because we do that from Q. So I think it's somewhere here. Just the sign it got wrong, as predicted. So I think I could still see it if we do this like, how far away is that? This is a half, this is 1. So 1, 2, 1, 2. Even 2.5 should be enough. And a little bit higher. Let's say 3, 4, that's certainly, I'll see it. That's my range. Yep. So that went totally wrong. I put it here instead of there, which is my sign issue. But I really go to bed now. It gets ridiculously late. So good night. Thank you for keeping me company.